have to a lot of regular fire incident operation. So that kind of benefit me today as I learn about fire safety and fire engineering and looking at other codes, I realized why certain requirements are written in a certain way. I hope you guys can hear my voice, right? Malaban, is the voice okay? Okay, good.
It's good.
All right. Then I went over to Middle East about 15 years ago to work with the authority right here, to continue with what I've done when I was in Singapore. The only difference would be out here, NFPA seemed to be the main standard and code. Then I went to consultant, to expose myself to getting into consultancy services. Okay? Where every day, my job pretty much writing a lot of fire strategies. From that experience, I learned a lot about interpretation of the NFPA. Okay? Because when we apply the process, there's a lot of effort trying to analyze what certain requirements meant and how they actually correctly cross-reference to the NFPA. Now, the topic today is cause and effect. Can you see the slide? Malabar, can the slide be seen?
Not yet, Mohammed. Not yet.
Okay, let me try.
Can you try again?
Okay, how about now?
Oh, yes, good. Please go ahead.
Okay. So it's introductory to cause and effect. I think cause and effect, to me, I feel a subject which has generally applied wrongly and misunderstood quite throughout over the various sectors of the same industry. For example, those working in facility management, consultants, and contractors. Okay. Why I think this has been misunderstood in general? I think it's because you can't find the information just in one book. Initially, when I came up with this, when Malaban and I came up with this topic, cause and effect, we thought we will, put it against NFPA 72. But then I realized cause and effect is not a set of information that you can find just in NFPA 72. It covers the other NFPA, NFPA 1, 72, 101, 5000, SME, depending on the system that you are looking at to understand cause and effect. In NFPA 72, there is nowhere, or in fact, throughout the NFPA, you will never find the word cause and effect. Okay, you will find phrases like input and output metrics in NFPA 72. You'll find phrases like integrated system testing. Okay, but cause and effect, that terminology, cause and effect, is not found anywhere in NFPA. Okay, so if you try to Google and look for that terminology, you probably be disappointed, you will not find it. But it means an activity that goes into an input of a particular processor that gives an effect, the output. Okay, so cause and effect is basically what input output matrix means. It is a means to verify the integration between systems. Okay, it can be active and passive to determine whether the systems are all activated according to the fire strategy. So fire strategy, you may ask, who will then write this fire strategy? There was once somebody came to me recently asking about whether a fire alarm should happen on the first knock or second knock. Who decides positive alarm sequence? Who decides certain type of fire alarm configuration? So my answer to them was, it should be decided by a fire engineer. Okay? Why? Because a fire engineer is expected to have the holistic knowledge about all fire safety systems, okay, from passive right up to active. Like he not only knows fire alarm system, he needs to know the architectural fire safety, where the egress are, whether the egress systems have been designed for simultaneous evacuation, or was it designed for partial evacuation. So a fire engineer should be looking into this, okay? And of course, he needs to have sensible knowledge of fire engineering fundamentals. I think NFPA has already came up with a definition for the category of fire engineers. It's not anymore something unknown. What is a fire engineer? Okay, very often we associate fire engineer with someone who is actually a sprinkler design engineer or is a fire alarm design engineer. Okay, but it is not. It should be. It can be originally a fire alarm engineer who eventually expands his knowledge to understand the full spectrum of fire engineering system, the fundamentals, and eventually he is able to offer sensible thinking into fire safety system. Okay. So if you look at NFPA 72, yes, there is a set of basic discussion in chapter 21. It says emergency control function interfaces, okay, which discusses very briefly about the main systems in a particular building. Okay. For example, the lifts, okay, evacuation sounders. Okay. So does the cause and effect ends there in NFPA 72? No, it covers a lot more. NFPA 72 is a book that gives you whatever systems that are directly associated with fire alarm system. Okay? But there are other third-party systems that are not directly interconnected to a fire alarm system, but it forms part of the holistic fire safety system. Okay? Take, for example, cause and effect, or a damper, escalator. So all this you will not find the direct immediate information about all this in the NFPA 72. Can everyone follow me so far? If there is any questions that you like to raise, please do so. You can either type or you can raise up live.
Sorry, Mohammed, we have a suggestion. Mohammed, can you hear me?
Yes, I can.
Oh, the suggestion is okay, let me bear with me.
Hello?
Yeah, Mohammed, yes, sorry. When you are projecting the PowerPoint, your slides, can you click on the full screen view when you're using the PowerPoint?
Like this?
Can you click on the full screen view, the PowerPoint show icon at the bottom? When you're using the PowerPoint?
Yeah, yeah.
Okay, sure, thanks.
Can everyone see this now? Can you see the slides now?
No, not yet, not yet.
Let me try one more time. Okay, can you see the slide now?
Yes. Thank you, Mohammed.
Okay, okay. I think I will not get out from the sharing mode. I will keep it this way. So, these discussions on cause and effect of other systems are found in other NFPA. So there is a need for engineers to spend time reading the other NFPA and try to draw out the information that is related to the cause and effect of a particular system. Now, there is also a misconception about cause and effect, which I realize needs to be addressed. Like, for example, not engineers, but usually like clients, owners, who are not very intimate with fire alarm system. They thought that cause and effect is only activated by a smoke detector, nothing else. Okay, so this is not true. Cause and effect can also be manual fault point, can be manual override from manual override devices. So inputs can be from more than just a smoke detector. And like I mentioned earlier, all fire safety systems, okay, has various way or configuration where they will be activated or deactivated. Very often, I feel consultants will jump into cause and effect, which is a bit way too simplistic, where a single activation of, say, smoke detector, every system will be activated. Okay, that includes releasing the security door lock, not only releasing the lock, but to open the door automatically. All leaves need to be recalled. Every single system needs to be activated all at the same time. Okay, this is not correct. Okay, why cause and effect for a particular system have been written specific to those that particular system is also has to do with the holistic behavior of the occupant plus the air movement inside the building. Okay. For example, if there is an activation of a detector in a particular floor of a high-rise building, where the staircases are obviously required to be staircase pressurized. If smoke extract system and all the stair pressurization happen simultaneously, this may not give the correct performance. You may have fans running, okay, but the performance of those fans will be compromised. Okay, why? Because air movements in the building have not been taken into account, and designing this. Because when the consultant designs staircase pressurization, very rare I see design report that get into the natural air movement in a particular building in a particular season. Okay, so to have all systems activated all simultaneously is not correct. Okay, so this can be discussed in a separate session where every system will have their own way. Okay, so integrated system testing, yes, but not every system activated all at the same time, because that is going to be chaotic. Okay, and not only that, just imagine testing of those systems, okay, is going to be quite a headache. Okay? So imagine you have various systems to be tested in a particular project, and all you can do is to test one system at a time. Okay, so that will be so time consuming, and it is going to be, if the project has not been handed over, it will be time consuming. If it has been handed over and occupied, it will be very disruptive to business continuity. Okay? So that's NFPA has written cost and effect differently for different systems. The other misconception is resetting being done in only in one location. It can be done in one location. It can also be done remotely. Okay, so there are options given in NFPA. The other misconception is about silencing. Okay, silencing, which has been understood in general, something that can be done by anyone. Okay, for testing purpose, yes, the appointed engineer or independent testing agency, they can do the silencing of fire-alarm system just to see whether the systems are working as intended. But in reality, other than that, okay, during a normal event, normal time, and there is an incident, fire alarm activated, silence can only be done by fire responder, not the building owner, not the FM person, nobody. Not be done by fire responder. Why this? I say it's also important information because then this will drive the expectation of owners and also designers differently. The other misconception about cause and effect is the mixing of standards and codes. Very often, also I came across from my experience, the habit of pick and choose standards or requirements from various standards of origin. For example, taking from British standards and a bit from NFPA, and trying to mix them and come out with whatever that makes sense to them. This should not be practiced, because when you start to take requirements out of context, you may lose out on other cross-referencing that has effect on the requirement that you have taken out to mix with another requirement. Okay. For example, when you take for example, the lift operation based on American standard, okay, does not addresses the flooding in the lift pit. Whereas if we look at the EN standard, it doesn't address that. Okay, so what has that flooding has to do with cause and effect? Because it will trigger sensors that will activate automatically the pit, some pump in the pit, right? So there are other requirements where when you start to mix them, you are actually putting, you are coming with hybrid cause and effect that will become very difficult to troubleshoot as you go deeper into construction, even after handing over during testing. Hopefully, cause and effect can be made correct at the point of handing over, so that facility management team, when they take over, they have a cause and effect in a particular building which makes sense. Right? So as you design, as a designer, you need to just pick a particular standard. Obviously, the driving factor here is the authority. Okay? If the authority has assign NFPA as the main standard of code, then just stick to it. You don't have to move to other standards. This is my opinion. Okay, unless you feel NFPA does not address certain systems. But from my experience, I feel NFPA is a good set of standards. If a person may not find the requirement that they were hoping to find, that's because those requirements probably are written somewhere else in the set of NFPA. So all you need to do is just dig further, research into NFPA, and probably refine that particular requirement, right? Before you jump into going to other standards and pick and choose and then fit into your situation. Okay, this is also another example where cause and effect for the lift, escalator, and travelator is covered in the SPA 17.1, 101, and 72. So you'll be surprised. Okay. Very often when we talk about these lifts, escalators, and travelators, we'll quickly jump into one particular code, which is 72. Yes, 72 has it. Okay, 72, NFPA 72 covers the fireman operation and other than that. But you also need to have a look deeper into 17.1 and 101. Just take, for example, this particular requirement where the lift recall for all lifts is actually activated by a smoke detector located in the lift lobby, and that smoke detector should not be more than about 6.4 meters from the center of the lift door. Okay, so very often you probably come across where when there's fire detection, all lifts are actually being recalled. Okay, and everybody goes away happy, the lifts are all recalled. But NFPA gives the correct, sensible cause and effect. Okay, it should be in the manner that is shown in the slide. Why is it in this way? First, because we need to have in mind NFPA is a document that's written to be as sensible as possible, make sense and logical as much as possible. It does not say, it does not prohibit evacuation using the lift. Okay, it doesn't. Only us, we say do not use lift during fire. Okay, but if you look further into NFPA, it says using lift for evacuation is not prohibited. Okay, but at the same time, when the smoke has been very close to the lift lobby, okay, it is going to compromise the fire compartment of the lift shaft. That's where the lift needs to be stopped, recalled to the ground, and stopped. Otherwise, people can continue using the lift. Okay, so that makes sense because the lifts, using lifts, this can be a bit controversial. You may think that this is not the correct practice, but I'm just talking about the perspective of the NFPA only. Okay, nobody is stopping anyone from saying do not use the lift. That is quite common practice anywhere in the world where when there's an emergency, fire evacuation, don't use the lift. But NFPA doesn't write that way. You can still, people can still use the lift to evacuate because the smoke is somewhere else. When the smoke is just at the door of the lift, stop the lift, bring it down, right? The other advantage of this is to bring down, to recall lifts. Hello, is everybody listening? Right, let me continue. To recall leaves, you need a generator. You cannot use battery system to recall leaves. So an NFPA or SPA 17.1 permits the recall of leaves one at a time. You don't need to recall leaves simultaneously. Okay. So this was also logical and sensible, so that the generator capacity does not have to be be subjected to unnecessary additional power just to bring the leaves. The leaves are permitted to be recalled one at a time. So this is also part of the cause and effect. To recall one at a time. To recall which leaves first? To recall the leaves which is nearest to the to recall the leaf which has the detector that has been compromised, the nearest to that particular smoke detector in the body. Okay, so if you want to have other leaves recalled, it's not wrong, but you can do it one at a time. There isn't a need to recall everything at the same time. So that is how it differs. And also escalators, is permitted to stop. Okay, whether or not it will go reverse way escalators, it all depends. Okay, so not necessary when there is fire detection, escalators must stop and then change direction to the egress. It doesn't have to be in that manner. Okay, if you look into SME, A17.1, you'll find that escalators can be programmed during a fire detection to just stop. But in other situations where you are going to use escalator as part of the evacuation, yes, you should make them reverse into egress direction. So these are options. Okay, so it's good to know cause and effect properly so that your design is optimum. Okay. Is there any question? Is everyone hearing my voice? Okay, I will continue. Okay.
Your mic is fine, Mohammed. Yes.
Okay, cool. The next system, major system that we also come across is the smoke control system. Okay, this smoke control system requires in-depth understanding about how it is being activated. Once again, it should not be a case where when there's a fire detection somewhere in the building and all smoke control systems are activated simultaneously. This will, you have the fans working, but you will not have the performance achieved. When I say performance, we're looking at, for example, staircase pressurization. The performance will be the airflow, the pressure, differential pressure across closed barriers, and also the door opening force, right? So you may not have this, and you don't have these parameters given by the system. That means it's not functioning as intended. It's not functioning as designed. Okay. to put that easy to understand is, for example, if you are going to drive a fast car like a Ferrari, you need to have a proper track, okay, a race track. Then the Ferrari can perform and make you happy. But if you drive a Ferrari in a normal, road, you can't drive Ferrari to the maximum and it doesn't perform, and you be very upset. Okay, it still moves, but it can't perform because the road is not correct. Okay, so the same for smoke control system, it needs to be activated according to suggested by NFPA. Okay? It can be a smoke extract system, it can be staircase pressurized system, okay? It can just be what we call it, airflow system. It's either activated by smoke detector, flow switch, sprinkler, flow switch, or even manual power point. Okay, generally, manual power point is not permitted to activate smoke control system or the pressurization system. Why? Generally, okay, because there is a concern about a person activating manual power point outside the smoke zone and activating the wrong smoke control system in the wrong zone. So, as much as possible, try to avoid activating smoke extract system or staircase pressurization system by a manual means. Otherwise, it should be activated by automatic detection or sprinkler flow switch. Even for sprinkler flow switch, it should be a flow switch of a sprinkler in the sprinkler zone, which is within the smoke control zone. We can go deeper into this in a separate session covered in NFPA 92 and also NFPA 13. NFPA 1 covers about the detectors that is activating the smoke control system. Okay, for example, staircase pressurization, okay, must be activated by a detector which is located not more than 3 meters away from the staircase. There was one time somebody came to me. So if there is no smoke detector within 3 meters of the staircase, so what will happen? So you don't have a staircase pressurization activated at all. So my answer to him, if your fire alarm system smoke detection placement has been completed and there isn't any detector within 3 meters of the staircase door, then you just have to provide additional. Okay, so basically, as a designer, the fire alarm guy needs to know. He's an electrical guy, so he needs to speak to the mechanical guy and ask, "Are you going to provide a staircase pressurization system?" If the answer is no, you go away. If the answer is yes, immediately you need to place a sign detector not more than 3 meters from the door of the staircase. Then you develop your other spacing from that onwards. Okay? And the mechanical guy, he needs to speak to the architect to find out, is this a high rise or is this a low rise? If it's a high rise building, then pressurization system becomes mandatory. Okay? If the architect doesn't have any answer to it, then it's obvious a fire engineer needs to be appointed to come into the project. Okay? To make sure the fire holistic fire safety system makes sense. They all can interact correctly. That's why fire engineer becomes critical in projects. That's how I actually that's what my involvement in projects most of the time. Okay, sometimes I get into commissioning. Okay, but the other part of my role is to make sure all fire safety systems they interact with each other in a sensible, correct way. Okay, if systems have been done differently from NFPA, then I have to put my fire engineering knowledge into practice to make sense out of whatever that has been deviating. Okay, usually not too much. The deviating part is usually leads to whether the first knock bring up the alarm or the second knock. Okay, but this will bridge the gap between what the NFPA requirement says and what has been done at site. Okay, this gap will always be there, and unfortunately, because as the project becomes bigger, more systems, there is always a tendency of oversight on interaction between system, mechanical system, electrical system, architectural system. So fire engineer comes and try to bridge the gap. The other one is AHU shutdown, air handling unit, a machine that cools down, that distributes cold air to the whole building. Okay, it's called air handling unit. Okay, shutting them down altogether. Yeah, this is permitted in NFPA. Okay, but this is again a bit too simplistic in my opinion. It should be looked into in more depth. Okay, because not all AHU should be shut down, because some areas need to retain the cooling system. Okay? For example, FCC, okay? Fire Command Center, or in NFPA it's called Emergency Command Center. So cooling in the FCC, what is it for? Is to retain comfort, okay? Comfort to fire responders. Okay? Not to make them, because when during an emergency, during a fire operation, fire responders get hooked up, so they perspire too much. Not mentioning the attire that they put on are very thick, so it becomes hot, they sweat a lot. So it needs to have a very cooling environment. Okay, so to facilitate the incident command coming from FCC. And then fire pump room also. So some fire pump rooms are designed with cooling. Okay, you don't necessarily need natural ventilation. That depends of what pump you need in there. Is it a diesel driven or is it electrical driven? Okay? So the point here being, just to emphasize, AHU can be shut down in phases depending on areas. It doesn't necessarily need to shut down all at the same time. Another thing about AHU is there will always a need to have smoke duct detector at the supply side of AHU. This detector does not activate fire alarm. Okay, it is a silent activation. Okay? What happens is it will pick up smoke coming from somewhere, most likely coming from a burnt fan. Okay, it picks up, and then it will give a silent alarm, visual alarm, a visual alarm or audible alarm in the FCC only. It doesn't trigger building activation. Okay, it's a small incident happening in the AHU. So mitigation can be initiated to put out the fire. Okay. The other system, again, just in general, the door release. Okay, if you notice, some buildings they have fire rated doors or smoke doors that are held open for practical reasons. Okay, you have this happening usually in schools and also in hospitals, healthcare occupancy. Okay. Then when the fire alarm is activated, all the doors are closed. regardless of which detector is activated. So NFPA does not require this. It only says these doors to be released by the assigned detector, which is not more than 1.5 meters away, front and back of the door. Okay? Only that particular detector, when it's activated, smoke detector, when it's activated, will release the magnets, the holding devices to the door, and therefore the door will be closed. When it's closed, it's called automatic closing. Okay, so if you look at NFPA, there are two types of closers. One is set closer, the other one is automatic closer. Okay, you may think that they are the same. They are not. Yeah. Okay, it sounds the same. You may think it's the same, but NFPA make a distinction between them. The set closer is the one that the closer behind every fire-rated doors. Automatic closer is the same, except it has magnets to hold them open and being released only when the assigned smoke detector is activated. Okay? Physically, they look the same, but operation-wise, they are not the same. Thus, the NFPA try to make a distinction between the two. And also, this does not raise a general alarm in the building. It only releases the door leaves and put the door leaves into their normally closed position. Now the next one is clean agent system. Excuse me.
Mohammed, sorry to interrupt. We have a question from Bala. Bala, would you like to ask the question, please?
Yeah, sure. Mohammed, actually, when we are connecting a duct detectors to the AHU, is that to be monitored as a supervisory or to be triggered as an alarm?
It functions just like any other detectors. If it's activated, it will create as alarm in the fire panel, but it doesn't activate the general alarm of the building. It doesn't require evacuation of the building. If the smoke duct detector is faulty, short-circuited, open-circuited, removed for whatever reason, it becomes supervisory signal or trouble signal to the fire alarm panel.
Okay, thank you.
The only difference is it doesn't activate the building evacuation. But if you want to program the fire alarm evacuation in the manner that you think makes sense, nobody is stopping you. It's just that it may be unnecessarily call it destructive to building occupancy. Okay. But if you think you want to raise it to the client, to the owner, your opinion, maybe you say, you know what, this is still a fire. The fan is on fire, overheating, on fire, a small fire in AHU. I think we should evacuate the building. If the owner agrees, say, okay, you can program it in the way that you think that meets the fire objective of that particular fire system. Okay? Fire engineers will have to state the objectives of having fire safety system. Objective could be protecting occupancy, protecting property. Okay? Now, let's come to clean agent system. This clean agent system is also a system that surprisingly misunderstood by many. Okay, I'm sure you all would agree that clean agent system is a system that is activated by automatic detection only. Okay, which means the protected room must have smoke detectors. Okay, and the industry, for me, from the time I came to this part of the world, okay, I have seen just this, right? And when I say no, a clean agent protected room, a clean agent system does not require the room to have automatic detectors. Depend on what you want. Okay, you can also have just manual activation. Someone will say, okay, Muhammad, you're not sane. Okay? You are weird. But the truth is, NFPA 2001 allows the protected room not necessary to have automatic detectors. You can purely have the room without anything, just manual override. Okay? But very often you have this. Okay, fine. You will have both. In our experiences in this part of the world, you see, or probably in other part of the world, you see a clean agent protected room having both manual override and automatic detectors. Now, automatic detectors also come usually it comes in two configurations, but usually we see one. And what is that? The cross zone. But the word cross zone is also not mentioned anywhere in NFPA 72. Okay. We have somebody raising hand. Muhammad Amir. We have a question, Muhammad Amir.
Yeah. Are you hearing me?
Yes.
Yeah. Yes, you are right that NFPA 2001 doesn't say that it should be cross zone or something like that, because it depends on the basically what type of protection we are going to give in that hazard room. Basically, for the panels, we can directly give this one direct release over there.
Okay.
And similarly, the same is for the cross zoning. That even the cross zoning is not required. That's what I want to add.
Okay, thank you. So we have someone also concurring that automatic detection is not something, a default system that you need in a clean agent protected room. So the fire detection for clean agent system, you can either have a direct activation or you can have a cross zoning. I use the terminology cross zoning because it seems like we are familiar with that phrase and it's easy to understand what cross zoning means. Basically, two detectors coming from two different loops. Okay, when they are activated, both are activated, then it's considered fire. Otherwise, one is not. But if you look at NFPA 2001, it doesn't state how to be done. Basically, 2001 detection system for clean agent system refers to NFPA 72. And NFPA 72 also doesn't stipulate when the alarm should come on. Is it on the first knock or is it on the second knock? Okay. Recently, I had an experience about a configuration where the first knock was made to cause a building evacuation. Okay, not the second knock. So my take on this was I said it should not be that way, because if you look into NFPA 72, okay, first knock and second knock arrangement is allowed to give a level of redundancy, okay, so that the system is robust. So you don't just evacuate the building because there is a first detection happening. Yeah. If you want to do that, it's fine. But why do you have second knock? Okay. If you are going to have two detectors to cause a fire signal, so if you are going to evacuate on the first knock, then it doesn't meet the intent of having the double knock. Okay. Double knock also applies in a positive alarm sequence where you have investigation and whatnot. So always look into what is the purpose of having certain things. Double knock, two knocks, positive alarm sequence. Why you have all this? So that you are given a time to determine whether the fire is genuine or not. Okay. In the meantime, the fire is not confirmed yet. So if the fire is not confirmed, why do you need to evacuate the occupant? Okay. So clean agent as a whole also have a set of its own way of cause and effect. Okay. And Clean Agent 2001 stipulate things like the first bell, the second bell, okay, high pressure discharge, low pressure discharge. Okay, all this will form part of the total cause and effect associated to clean agent system. So it's not really straightforward. Will have to be discussed in a separate session. Then we have
Mohammed, sorry to interrupt. We have two questions, one from Andy. Andy, would you like to post your question, please?
Andy.
Hello, Andy? Hello, Andy. Okay, let me read out the question. What he has asked me is, it's a follow-up question. If the FACP does not monitor, supervise activation of duct detector, should give building alarm or not?
Yeah, the duct, as far as NFPA 72, duct detector is NFPA 92. Okay, so if we go along with NFPA, detectors need to be supervised, okay, whether it's going to be called trouble or is going to alarm. But if the detector is somehow not configured to be monitored for its performance, supervisory and troubling, then it's not compliant. So try to make that detector compliant first. Then you configure whether the detector activation will be a silent or it will evacuate the building. It's up to you. But if you go with NFPA, building evacuation is not required for an activation of smoke duct detector. I hope that addresses your question.
Oh, and we have another question from Vinod. Vinod, would you like to ask the question?
Go on, Vinod.
Hi, good evening.
Yes, Vinod.
Yeah, I would like to ask regarding the HSSD system and the detection system provided in an electrical room, where the electrical enclosures are provided with the HSSD system and the room is protected with the addressable detector system. If we consider the double knock logic or like cross zone logic, in case there is a smoke only inside the electrical enclosure and HSSD system is activated, how the clean agent system I can activate?
What is HSSD?
High sensitivity smoke detector, aspiration system, air sampling system.
So the enclosure, okay. Electrical panels, by NFPA, you don't need to have a separate aspirated system in the electrical enclosure. But if you are going to have that arrangement, and that enclosure has its own detection system, okay, then again, this is up to the fire engineer to decide whether that detection will be interfaced with the detector inside that electrical room. Okay, but if we go along with NFPA 2001, which makes reference to NFPA 72, pertaining to detection alone, there isn't any discussion about first knock, second knock, cross zone, whatever. It is kept open. If you want to do it that way, go ahead. Okay. But what I said is, if you're going to have two detectors, what is the purpose? The purpose is redundancy, which means if first detector happens, is it a fire? No. Okay. If it's not a fire, you should not evacuate the building. Okay. Let the second detector to be activated. Then it's a confirmed fire. Everybody agrees. Then that's where the discharge will start. The counting of the clean agent discharge will happen, and evacuation can take place. Okay. But if you want to do it differently, it's not wrong. NFPA is minimum, but you want to exceed, you can, but just be aware of the implication of exceeding. Sometimes more does not necessarily mean good or correct. It can be wrong. Okay.
Okay. Yeah. Got it. Got it. Thank you.
Mohammed, we have another question. I think it will be better if you can read on the chat. It's
Okay, just a second.
descriptive from Amni.
Amni, okay.
Yes.
Let me read the question. For clean agent, does codes or manufacturers suggest that only smoke detectors shall be used for automatic detection? Clean agent system, no, it doesn't say you need to have smoke. Smoke, no, it can be others. Okay, depend on the suitability of that particular environment. But have in mind, clean agent is useful in putting out fire, incipient fires fast. Okay, so you really don't want to put detectors like heat detectors. Why? Because the response time may be slower. Not maybe, it is always slower. Smoke detector is faster. In fact, if you want to make it even faster, you can use VESDA. Okay, VESDA as the automatic detection for clean agent. So it's faster, and then you can, if it's confirmed fire, the clean agent can put out a fire and it serves the purpose. The second question, what if the end user insists that they want to wait for the fire to grow enough that it gets detected? Not advisable, because then if this is going, okay, let me read the whole question in full. What if the end user insists that they want to wait for the fire to grow enough that it gets detected by heat detector and then release the agent? Okay. If the end user wants this in this manner, then there is a need to look into the fire size. Okay, look into the fire size, and the implication is the clean agent quantity is probably going to be more. Okay, when it's more, the other things will have a domino effect, like the fighting and whatnot. So there'll be implication. This comes from Amnio.
Amnio, and there's one more question.
Okay, one more below.
From Amnio.
Alan.
No, there's a third question from Amnio regarding the heat detector.
But can we advise end user against using heat detector with substantiating of code or any study? The only suggestion to client not to use heat detector is to tell them what I've just mentioned just now, the two things. Heat detector responds slower than smoke detector. Okay. Earlier on I said maybe. No, it's not maybe, it's true. Heat detector responds slower than smoke detector. In fact, the purpose of clean agent system is to put out the fire fast, okay, before it becomes big. Otherwise, why you put clean agent? You put sprinkler. You don't need clean agent system. It's complicated. Just put a sprinkler system and finish. We need to know the concern of the client. What is their concern? Why you want to destroy everything? By the time the heat detector is picking up the fire, probably the equipment that is being protected is damaged, finished. If you tell the client, if you are going to wait for that to happen, please save your money, just stay with sprinkler. And if he says the building has no sprinkler, then you say you don't need clean agent system. Okay, clean agent system is only used as an alternative to sprinkler. So if you don't have a sprinkler, what's there to alternate? You don't need, there isn't a need for any alternative suppression system. Okay, but of course, client will say, no, I insist that I want a clean agent system. So, okay, give them the clean agent system. You can tell them the heat detector will pick up slower. Okay, and if that happens, the medium, the quantity of FM200 or NOVAC will be more. bigger tanks, bigger space, more pipes. Okay, next one. I hope I can answer the last one. Is it allowed by code for the fire alarm system to just provide an alarm output that will be an input for building management system? Then BMS will shut down. Yes, we can have this. Is it allowed by NFPA, okay, to provide alarm output as an input to so no, I have to check on this. Okay, you are saying that the output from the fire alarm panel goes into BMS, and BMS actually will activate the AHU. Okay, usually the signal will go straight into BMS, and BMS will go to AHU. So now you're asking, I have to check on this. If you can, Alan, I think this this message inquiry comes from Alan Sabado. Okay, perhaps this Mr. Alan Sabado can email to Malaban or to us so that I can respond to this in a separate time. Right. Do you have any other question? Otherwise, let me quickly end this. But before that, I'd like to just show this slide. Okay, this slide is the template of cause and effect that everybody should be using. You can modify a bit, okay, but not too much off from this cause and effect metric. Okay, that's all. Thank you very much for your time listening to the discussion.
Thank you, Mohammed.
Hey, thank you very much. Thank you very much. If you have any questions, please feel free to ask. Oh, there is one from Vinod. Vinod, would you like to ask the question, please?
Okay, I will read the question.
Okay.
Inquiry comes from Mr. Vinod. In case of maintenance switch disconnected or solenoid cable disconnected, we need to generate an alarm? No. There is a supervisory signal at the panel. Okay.
Okay.
Supervisory signal coming from the clean agent panel.
All right.
Okay.
Thank you. Thank you.
Most welcome, Vinod. So I hope this short session will encourage everybody's participant to move on to a deeper session where we can discuss about more in depth about the specific cause and effect for specific system.
Everyone, thank you very much. If there are no other questions, we can wind up the session. And before we close, just to inform you, we'll be emailing the video recording of this session. If you have any questions later on, just email to us. I believe everyone has my email ID. It's malavan@serendiptraining.com. We'll do the best we can to help you. Thank you very much. Mohammed, you're fine.
Okay.